All right, let's get into it. Today, we're going to take a look at a really world-class mathematics research group based right in Thailand and explore how their super abstract work is having this huge, tangible impact on some of the biggest challenges we all face today.
And if you want to understand just how big their impact is, just look at this map. Seriously. This isn't just a bunch of lines on a screen. It's a network of brilliant minds. It shows the global collaborations of the KMUT Fixed Point Theory and Application Research Group, connecting researchers across more than 30 countries. This is a true powerhouse of mathematical innovation.
So, the big question is, how did they become such an international player? Let's break down what makes them a genuinely global hub for mathematics, all based out of King Mongkut's University of Technology Thonburi.
This slide really breaks it all down for us. Each of these little icons represents a different kind of connection. We're talking everything from joint projects and publications to a constant flow of visiting scholars. This kind of deep international collaboration with universities from Germany and the UK all the way to Nigeria and South Korea, well, that's what makes them a world leader in their field.
But what exactly is their field? Well, they focus on something called fixed point theory. Now, I know, it sounds incredibly abstract, but I promise you, the core idea behind it is surprisingly simple and incredibly powerful. So, let's really get into it. What on earth is this powerful idea that's at the very center of all their work?
Okay, at its heart, it's this. Stick with me here. Imagine you take a map of your city. You crumple it up into a ball, and then you drop that crumpled ball anywhere on top of the original flat map. I guarantee you, there will be at least one single point on that crumpled map that sits directly above its identical spot on the flat one. That single unmoving point, that's a fixed point. It's an anchor in a sea of change.
And here's a more, let's say, mathy way to visualize it. If you graph some kind of process or a function, that's the curve you see here. The fixed point is the exact spot where that graph crosses the simple straight line of input equals output. It's that perfect moment of balance, of equilibrium. And you know what? Finding that single point of stability is the secret to solving an unbelievable number of problems.
So that's the theory. Cool, right? But how does this elegant idea actually lead to practical, real-world innovation? Let's see how it's shaping the world all around us.
Well, this is where the magic happens. This group's central mission is to turn that deep theory into practical tools. They take these concepts and forge them into what are called efficient iterative algorithms, which are basically, sets of rules that let a computer solve a problem step by step, getting closer and closer to that perfect fixed point answer with every single pass. It's how we tackle problems that not too long ago were thought to be completely unsolvable.
And this is why all of that matters so much. The algorithms they're developing are the hidden engines behind so many technologies we depend on every single day. I mean, take machine learning. An AI model is constantly adjusting itself, trying to find the best possible answer. Well, that's its fixed point. These algorithms are like a super fast GPS, guiding that AI directly to its destination, to that point of maximum accuracy.
And the proof is in the numbers. I mean, get this. The sheer volume of their work is just staggering. We're talking over 900 publications.
But what's even crazier is the impact. Their research has been cited more than 10,000 times. That means their ideas aren't just sitting on a shelf somewhere. They are actively being used to fuel new discoveries all over the world. This level of global impact is just incredible. And what's so amazing is that it all started out pretty humbly, as a small, really focused group of PhD students that has now blossomed into a nationally recognized center of excellence.
But a world-class research lab is about so much more than just numbers and papers. At the end of the day, it's about the people and the culture.
And you can really feel that vibe right here. On one side, you see the intense, focused environment of a top-tier research lab. And on the other, you see the vibrant, supportive community that makes it all possible. They've absolutely mastered that balance between hard work and human connection.
They really go out of their way to foster this collaborative spirit, and not just in the lab, but through shared experiences, like here, celebrating the new year together. Or even just simple team dinners. These are the moments that build the trust and the personal bonds that are so essential for doing truly groundbreaking work.
And that kind of welcoming environment, well, it's like a magnet for talent. It's exactly why they're able to attract the best minds from all around the globe through things like the UK's Turing Scheme or their postdoctoral fellowships, bringing in researchers from places like Germany, Nigeria, Pakistan, and India.
So what's next on the horizon? Well, this group is intensely focused on using its expertise to help craft a sustainable future for science and technology.
Their vision for the future is crystal clear. First, they're going to keep pushing the boundaries of the fundamental theory. Then, they're going to integrate their optimization work even more deeply with the explosive fields of AI and data science. And underpinning all of it is a deep commitment to making those vital international partnerships even stronger.
And at the end of the day, their highly specialized work fits perfectly into the bigger picture, the wider mission of their university, KMUT. They're a living, breathing example of how 65 years of academic wisdom can be harnessed to build the tools we desperately need for a sustainable future.
So the next time you see a self-driving car navigate a tricky turn or watch an AI generate a stunningly beautiful image, just remember what's happening beneath the surface. It's not magic, it's math. It's the constant, relentless search for that one stable, fixed point that makes it all work. So the real question isn't just how this will shape our future, it's how will you start to see this invisible framework all around you.